All right, let's look at the homework 7.3, problem number 2. All right, so let's evaluate this integral using trig substitution. All right, so this is, you have a square root of x squared plus 36 is 6 squared. So this is the type for tangent, right? So we're going to let x be. All right, so a in this case is 6, so it's going to be a 6 tangent of theta. All right, so let's go through the usual drills. So take the derivative of x with respect to theta. You're going to get 6 times secant squared of theta. All right, then we can just multiply through by d theta to get dx is equal to 6 secant squared of theta d theta. All right, so this is going to be equal to integral. All right, so if you plug in x equals 6 tangent of theta, all right, so you're going to get 6 squared, and there's a 6 squared pulled out with this square root, so it's going to be just 6. All right, then you have a tangent squared plus 1, so that's a secant squared. So with the square root, you're going to get just a secant of theta. All right, and dx just came out to be 6 secant squared of theta d theta. Right, so this is kind of nice. You have 6 on top and 6 on the bottom cancel out. Then you have secant square, and that is secant, so you can cancel one of the secant here. All right, so antiderivative secant of theta is equal to, and remember that antiderivative secant theta is natural log of absolute value of secant of theta plus tangent of theta, right? Then since this is an indefinite integral, so you're going to have a plus some constant c. All right, then we just need to rewrite this expression in terms of x. All right, so we're going to use this guy right here. Right from here, I'm going to divide through by 6 so that we have x over 6 is equal to tangent of theta. Right, so we know tangent, right, and we need to find secant of theta too. So I'm going to use a triangle here. So I'm going to draw a right triangle. Right, then you have a right angle here, and we have a theta there. Right, so tangent is opposite over adjacent. So I'm going to set opposite to be x and adjacent to be 6. Then hypotenuse is going to be a square root of x squared plus 6 squared, which is 36. Right, so remember, so this is the opposite, this is the adjacent, this is hypotenuse. Right, so if you want to find a secant, so you have a secant of theta is equal to hypotenuse over adjacent. So you will get square root of x squared plus 36 over 6. All right, so if you put everything in, you have natural log of absolute value of secant of theta is a square root of x squared plus 36. And then over 6. And plus tangent of theta is x over 6. So you're going to have a plus x. Right? Plus c. Right? Then one thing you can do is you can actually since you have a division inside, you can write it as, actually I'm going to call this a C1 and a C1. Right, then we can split it as a natural log of absolute value of, but you can actually also eliminate the absolute value sign because this quantity is never negative. So I'm going to go ahead and do that then. Right, this is going to be just a simple parentheses, right? Then minus natural log of 6. And plus some constant C1, right? But since natural log of 6 is constant, I'm going to just combine those two constants together. I'm going to put the just plus C there. All right, so that's the answer. So let's type it in. And here, all right? So what we got was natural log of, right, square root of x squared plus 36 and plus x, and then plus some constant c. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.